Hello, we will start with exercise 5C, which involves half angle, double angle, triple angle. Okay, so there are many problems in this particular exercise, but then we'll take up the easier problems in session number one. Okay, so exercise 5C, let me take you to question number one, sub question one. So they are asking you to evaluate a certain thing, and that thing is 2 sine 15 cos 15. Okay, now this is similar to 2 sine A cos A, right? And 2 sine A cos A is sine 2A. Okay, so let 15 be A. Let 15 be A. So this can be written as 2 sine A cos A. Okay, where we are assuming 15 degrees to be A. Now it is 2 sine A cos A. It is sine 2A, which is sine 2 into 15, which is sine 30, and the answer is half. Next problem, sub question 2. 1 minus 2 sine square 22.5. So I'm assuming this value to be A. 1 minus 2 sine square A. Now, if you remember, 1 minus 2 sine square theta or 2 sine square A will be cos 2A as per half angle. Okay, so this is written as cos 2A. So the answer will be 2 into 22.5. So this is cos 45, which is 1 by root 2. Sub question 3, 2 cos square 157.5 minus 1. So let this be A. So 2 cos square A minus 1. 2 cos square A, half angle formula is cos 2A. Okay. And cos 2A, replace the value of A, which is 157.5. Okay, so you'll have to multiply this 157.5 into 2. That is cos 315. Now this I leave it up to you. You can solve this divide by 90 method, that you can do it on your own. Okay. Sub question 4. Cos square pi by 12 minus sine square pi by 12. So let this be A. Now the angle is expressed in radians. So this is cos square A minus sine square A. Cos square A minus sine square A is cos 2A as per the half angle. So cos 2 into pi by 12, which is equal to cos pi by 6, and pi by 6 is 30 degrees converted into degrees, and cos 30 is root 3 by 2. That is your answer. Question number 5, half minus sine square 7 pi by 12, which is equal to 1 minus 2. Let this be A. 1 minus 2 sine square A upon 2. See, I've assumed this to be A, and also I have taken LCM. I've sent this 2 over here. 1 minus 2 sine square A is cos 2A upon 2. So 2 into A is 7 pi by 12 upon 2. So 2 ones are 2 6 are. Convert this into degrees. 7 into 180 by 6. Okay, divided by 6. So that is cos 210. The whole upon 2. Now cos 210, you can calculate it using divide by 90 method and get the answer. And the final answer has to be divided with this 2. This 2 has nothing to do with the trigonometric function. The final answer will be overall divided by 2. Okay, fine. Next problem. Next problem is question number 6. So this is cos pi by 8 into sin pi by 8. Okay. Now, if you take a look at this particular problem, first of all, I'll assume this to be A. So this is cos A into sin A. which can be written as sin A into cos A. Mathematically, it is quite valid. Then I will multiply and divide with 2. 2 sin A cos A upon 2. The purpose of division and multiplication with 2 is because we get a half angle formula over here. Sin 2A by 2. Sin 2 into A. A is pi by 8. Okay. I think I have copied this wrong. Sorry. This is 8 over here upon 2. So this is sin pi by 4 upon 2, which is sin 45 upon 2. Okay. Sin 45 upon 2. Now sin 45 is 1 by root 2 divided by, there is a 2 in the denominator. Okay. So 1 by root 2 into 1 by 2, which is 1 by 2 root 2. Fine. Let us go to question number 7. Okay. So 2 tan 22.5, that half I'm writing it as 22.5. 1 minus tan square 22.5. I'm taking this as A. So this is 2 tan A upon 1 minus tan square A. Okay. That is tan 2A. The half angle for tan 2A. This is the half angle for tan 2A. Okay. So tan 2 into A. A is 22.5. Okay. So tan 45, which is equal to 1. Eighth sub question. 8 cos cube pi by 9 minus 6 cos pi by 9. Take 2 common. 4 cos cube A. I'm taking pi by 9 as A. Declare pi by 9 as A into 3 cos A. Now this is triple angle formula. 2 into cos 3A. Okay. So 2 into cos 3 pi by 9. The value of A is pi by 9. So this is 2 cos pi by 3 is 180 by 3, which is 60. 2 into half. The answer is 1. Okay. So that was your question number 1. Let us go to question number 2, sub question 3. Okay. Sin theta is equal to half. Theta lies in fourth quadrant. They have given this to us. Okay. So from sin, first we'll calculate cos using triangle method, or you can also use identity. So this 1 is the opposite side. This 2 is the hypotenuse. So by Pythagoras theorem, okay, this is going to be 1. The adjacent side is going to be 1. Because root of 1 square plus 1 square. Okay. 1 second. I just made a mistake over here. So the third side. Okay. That will be root of 2 square minus 1 square. Okay. Which is equal to 4 minus 1, which is root 3. So the third side is root 3. Okay. I used Pythagoras theorem. Because root 3 square plus 1 square, that is 4, and the square root of 4 is this 2, which is the hypotenuse. Now, why this negative sign? Negative sign is because they have said theta lies in the fourth quadrant. Okay. Now, cos theta. Cos theta is adjacent upon hypotenuse. Root 3 by 2 with a positive sign because it's the fourth quadrant. Okay. So we got sine and cos. So first we'll calculate sine 2 theta, which is 2 sine theta cos theta. We have both the values ready with us. Sin theta is minus half and cos theta is root 3 by 2. So the answer is minus root 3 by 2. Okay. Question number 2, sub question 3. Now we'll solve cos 2 theta. I'm making use of half angle. So there are 4 formulas basically of cos 2 theta. I'll use this formula, cos square theta minus sin square theta. Don't go into tan and all. Don't apply tan formula. It will be requiring that value of tan theta otherwise. Tan theta we haven't calculated, but then it is easy to calculate tan theta over here. Tan theta is equal to 1 by root 3 with a negative sign. Opposite upon adjacent. Negative sign is because is the fourth quadrant. So for cos 2 theta, you can also apply tan 2 theta formula. Sorry, tan theta formula. We have this formula 1 minus tan square theta upon 1 plus tan square theta. But then there is no requirement of this. You can rely on the first three formulae. Okay. Yeah. So cos theta is root 3 by 2. And this is minus half. This values we have, cos theta and sin theta values we have. So this will be 3 by 4 minus 1 square is 1 by 4, which is 2 by 4, which is 1 by 2. And tan 2 theta. Tan 2 theta, again, no need of applying half angle over here. It's simply sin 2 theta upon cos 2 theta. So this divided by this particular value. Okay. Sin 2 theta upon cos 2 theta. So there are three more sub questions in question number 2. You can definitely practice this on your own, right? Question number 4. Question number 4. Derive 120 degrees from the functions of 60 and check it by using relations between functions of supplementary angles. So we'll solve, we'll get the values of 120 degree, all trigonometric functions of 120 degrees by two methods. First method is half angle method and the second method is complementary angle method. So sine 120, we'll start with sine. Okay. So now see, first method I'm doing, sine 2a is equal to 2 sine a cos a. This formula we know. So if it is sine 120, it will be 2 sine cos. Now the angle 2a gets converted into a, left to right. So 120 will get converted to 60 degrees. Okay. So that is 2 into root 3 by 2 into half. 2 is getting cancelled. The answer is root 3 by 2. So first part is clear. Then cos 2a. Cos 2a, again, there are four formulae basically for cos 2a. Okay, we can rely on any three, the first three. So it's cos square a minus sin square a. So cos 120. Okay, 120 half is 60. Cos square a minus sin square a. So half square minus root 3 by 2 the whole square. So this is going to be 1 by 4 minus 3 by 4, which is minus 2 by 4. The answer is minus half. Okay. So the answer for cos 120 is minus half. I've written over here. Now tan, cot, sec, cosec, you can directly calculate. Tan is sine upon cos. Okay. Sec is 1 upon cos. Cosec is 1 upon sine. And then cot 120 is 1 upon tan 120 or cos 120 upon sine 120. We'll go to method number 2 for the same problem. Sine 120 can be written as sine 60 plus 60. Okay. Or you can also write 90 plus 30, take standard angles. So this is A and this is B. Apply compound angle formula. Sine A cos B plus cos A is 60 sine B. Okay. So root 3 by 2 into half plus half into root 3 by 2. So root 3 plus root 3 is 2 root 3 upon 4. So the answer is root 3 by 2. Okay. Now let's check whether this and the previous answer was right. Yes, both the answers are matching. Fine. Now cos 120. Similarly, you can go ahead. Cos 60 plus 60 or cos 90 plus 30. Apply this formula cos A cos B. So cos A cos B minus sin A sin B. Just apply this formula. Okay. So this will be half into half minus root 3 by 2 into root 3 by 2, which is equal to 1 by 4 minus 3 by 4 minus 2 by 4, which is minus half. Okay. Cos 120 is minus half. Then tan, cot, sec, cosec, you can take reciprocals and solve. Fine. So that's how we have verified using compound angle formula. Both the methods I've given you. Okay. Let's start with question number 5. Sin theta is equal to A. Sin 2 theta is equal to B. First, we need to find out the value of cos theta in terms of A and B. Okay, so sine 2 theta, half angle of sine 2 theta is nothing but 2 sine theta cos theta. Okay, so sine 2 theta, the value is b, sine theta, the value is a into cos theta. Therefore, cos theta is equal to b upon 2a. B upon 2a. Fine. Let's go to question number 6. Oh, sorry, there is one more part remaining over here. They're asking us to eliminate theta. Find the relation between a and b not involving theta. So we have to eliminate theta. So to eliminate theta, I'll make use of fundamental identity sine square theta plus cos square theta is equal to 1. Sine square theta. Sine theta is a, so this will be a square. Cos theta is b upon 2a, which we just calculated. Okay, b upon 2a, right? So a square plus b square upon 4a square is equal to 1. Take LCM. 4a raised to 4 plus b square upon 4a square is equal to 1. A square into a square is a raised to 4, okay? And therefore, 4a raised to 4 plus b square is equal to 4a square. This is how we are eliminating theta now. The thing which I have put in the box bracket does not have theta in it. Okay? Let's go to question number 6. Fine. Sub question 1. Tan A is equal to 1 by 5. Now tan value is positive, so the answers will be in first quadrant and third quadrant. Fine. So they are asking tan 2A. Tan 2A is equal to 2 tan A upon 1 minus tan square A. Half angle formula, half angle or double angle, whatever you call. So this will be 2 tan A, 2 into 1 by 5. Okay. Upon 1 minus 1 by 5 the whole square. So that is 2 by 5 divided by, let's calculate this value, 1 minus 1 by 25. Okay. So 2 by 5 divided by 25 into 1, that is 25 minus 1, 24 upon 25. So 2 by 5 into 25 by 24. So this will be 5 upon 12. The value of tan A we have got. Okay. Now they're asking tan 4A. So I'll use the same formula, but then this time the right hand side 4a, this all values will get converted to 2a because of the half angle. Okay, so that I'll solve on the next page. So tan 4a is equal to 2 tan, this time the angle will be 2a, 1 minus tan square 2a. Now we have this particular value, tan 2a value we just calculated, that is 5 by 12. Okay, 1 minus 5 by 12 the whole square. This is how you'll get the value of tan 4a. Okay, and tan 45 minus 4a. Tan 45 minus 4a, we can use compound angle formula. This is a and this is b. So tan a minus tan b upon 1 plus tan a tan b. Okay, now we have this values. Tan 45 is 1 and tan 4a. Tan 4a value also we have just calculated over here. This value will be here and this value will be here. So you can put that value after simplification. Tan 45 is 1 and simplify this and get the value of tan 45 minus 4a. Okay. Let's go to question number 6, sub question 2. Yeah. A is obtuse angle whose sine is 5 by 13. So A is obtuse angle. So obtuse angle goes in the second quadrant, more than 90. And B is acute angle whose tan is 3 by 4. So B is over here in the first quadrant. It's acute angle. Okay. So sine A is obtuse is 5 by 13. This is what is given. Okay. So A is over here. This is 5. This is 13. Okay. Pythagoras theorem, the adjacent side will be 12. Root of 13 square minus 5 square. Okay. So cos A. Cos A will be minus 12 by 13. We are taking minus sign because A is in the second quadrant. Okay, and tan A. Tan A is 5 by 12. This also is negative because it's the second quadrant. Now, one more thing is given, tan B. B is acute. So B is over here. This is 3, this is 4. So by Pythagoras theorem, this will be 5. Okay. So sin B is 3 by 5. Cos B is 4 by 5. Both the values will be positive because is the first quadrant, B is in the first quadrant, so both the values will be positive. So we have all the values ready in front of us. All the 6 values, sin A, cos A, tan A, sin B, cos B, tan B. So first value which they are asking is sin 2B, half angle, 2 sin B, cos B. We have these values, you can put, okay, yes, cos B, sin B, these values, cos B, sin B, these values we have. You can put over here and calculate. And secondly, what they are asking is tan A minus B. Of course, a compound angle formula is required over here. So this is a direct formula, tan A minus tan B upon 1 plus tan A tan B. So this formula is applicable. You can just solve the problem further by putting the values of tan A and tan B. We already know the values of tan A and tan B. Okay. It's there over here on the first slide of the problem. So tan A and tan B, these values we can put over there and simplify. Okay. Now let us go to question number 10. Okay. Cos alpha is equal to 3 by 5. Okay. And cos beta is equal to 4 by 5. Alpha and beta are acute angles. So they are both in the first quadrant. So this is alpha, this is 3, this is 5. By Pythagoras theorem, this will be 4. This is beta, this is 4, this is 5. By Pythagoras theorem, this will be 3. Opposite side will be 3. Okay. Now, first of all, we are interested in calculating cos alpha minus beta by 2. But first, I'll be calculating cos alpha minus beta. Okay, by 2 afterwards. But then first, I'll calculate cos alpha minus beta. So first, I'll get the values of sin alpha and tan alpha. Standard values, I'll just calculate. So this is 4 upon 5. First quadrant, it is positive, and this is 4 by 3. And this is sin alpha, sin beta. Sin beta is equal to 3 by 5. Okay. And tan beta is equal to 3 by 4. Okay, these values are ready in front of us. Now, first I'm going to calculate cos alpha minus beta. So this is compound angle formula cos A minus B, which is cos alpha cos beta plus sin alpha sin beta. Okay, cos alpha. Cos alpha is, we have calculated this. So cos alpha, let me just show you. This is 3 by 5. 3 by 5 into cos beta. Cos beta is 4 by 5. Yes, these were the given values. 4 by 5 plus sin alpha sin beta. 4 by 5 and 3 by 5. So 12 plus 12, that is 24 by 24. Now cos 2 theta is equal to 2 cos square theta minus 1. Okay. So instead of 2 theta, I'm just putting alpha minus beta. Instead of 2 theta, I'm putting alpha minus beta. So what is the half of alpha minus beta? The half of alpha minus beta is alpha minus beta by 2. Okay, so I've used half angle over here. Now cos alpha minus beta is 24 by 25. 2 cos square alpha minus beta minus 1. Okay, this will remain as it is. And 24 by 25, this value we have already calculated. So 24 by 25 plus 1 is equal to 2 cos square alpha minus beta by 2. So this will be 49 by 25. 2 cos square alpha minus beta by 2. Okay, so this will be 49 upon 25 into 2 cos square minus alpha minus beta by 2. Taking square root on both the sides. So cos alpha minus beta by 2. Individual roots is applicable on the left hand side because it's multiplication and division. 2 is not a perfect square, so the root of 2 is 2. So this will be positive because the answers have to be in the first quadrant. They have mentioned alpha and beta are in the first quadrant. Okay. Let us go to question number 11. Question number 11. Yes. So cos a by 2 is equal to 12 by 13. Without using tables, find the value of sin A, cos A, and tan A. Okay. Now, first of all, cos A by 2. A by 2 is positive. So this A by 2 lies in first and fourth quadrant. Okay. So the answer can be in first and fourth quadrant. Fine. Now, if this is A by 2, so this will be 12 and the hypotenuse will be 13. By Pythagoras theorem, the opposite side will be 5. So sin A by 2. Sin A by 2 will be 5 by 13 and tan A by 2. Tan A by 2 will be 5 upon 12. But then sin and cos, sin and tan both will be either positive or negative. Positive for first quadrant, negative for fourth quadrant. But then cos is throughout it will be positive. Okay, see again, first quadrant sign will be positive, second, fourth quadrant it will be negative. Okay, same thing for tan because in the fourth quadrant will be cos and sec are positive. Now let us solve one values. They are asking sin A. Sin A is equal to 2 sin A by 2 cos A by 2. I've used half angle formula for sin 2A. Okay, I'll write that formula if you are confused. Sin 2A is equal to 2 sin A cos A. This is the formula. Okay, but then we are not interested in 2A. We require A. So the half of A will be A by 2. So we have the values sin A by 2 is plus minus 5 by 13. See, and cos A by 2. Cos A by 2, the value is 12 by 13. Okay. So this will be 60 into 2, that is 120 by 169. The answer will be positive or negative. Okay. Fine. Now we require cos A as well. But then first we'll calculate the value of cos 2A. Write the formula for cos 2A. Cos 2A is equal to cos square A minus sin square A. Okay. Therefore, cos A is equal to cos square A by 2 minus sin square A by 2. See, we have this A by 2 values. We don't have this. And we have to calculate cos A. So we have to write the same formula in terms of cos A. Okay. So A will become A by 2. Now cos A value we are supposed to calculate cos square A by 2. So cos A by 2 is 12 by 13, which is the whole square, and sin A by 2 plus minus 5 by 13. Okay, so this will be 144 upon 169 minus 25 upon 169. Okay, which is equal to 119 upon 169. The answer will be positive because this positive negative square is always positive. Fine. And tan 2A will be sin 2A upon cos 2A. Both the values we have, you can calculate sorry, not tan 2A, tan A value you can calculate using sin A upon cos A. Okay. Yeah. So let us go to question number 12. Okay. Tan X is equal to 12 upon 5. X and Y are in the same quadrant. Now see guys, when we speak about X, tan is positive in first and fourth. Okay. Now cos Y is negative. So cos is negative in the second and third quadrant. and they are saying X and Y are in the same quadrant. Okay, they are in the same quadrant. So which is the common quadrant over here? That is quadrant number 3. So we have to restrict our solution only to quadrant number 3. Okay, so now this is X, this is 12, this is 5. So by Pythagoras theorem, this will be 13. So sine X will be minus 12 upon 13, opposite upon hypotenuse. Why minus sign? Because third quadrant we have to restrict ourselves to. And cos X is equal to 5 upon 13. Again, it is from the third quadrant, so cos is negative. Here, this is y, so adjacent upon opposite. So by Pythagoras theorem, this will be 4. Okay. So sin y. Sin y is minus 4 by 5. Opposite upon hypotenuse, minus sign is because we have to consider only the third quadrant. And let's say tan y. Tan y is equal to 4 upon 3, opposite upon adjacent. We are taking negative positive sign for tan because it's a third quadrant. So we cannot use the negative sign over here. Fine. So these are the values that are there in front of us. Now what are they asking is first part, sine x plus y. They are asking sine x plus y. Okay, sine x plus y. So that is equal to sine x cos y plus cos x sin y. Now do we have all these values? Yes, we have calculated all these values. Okay, you can refer the previous slide and see. We have calculated all the values, sin x, cos x, sin y, cos y, all these values either was given or we calculated it. Okay, so you can put those values over here and get the answer. And the next part is cos y by 2. We require cos y by 2. Now y can become y by 2 only by half angle. So we have to involve certain formula of cos. So cos 2y guys is 2 cos square y minus 1. 2 cos square y minus 1. This is the known formula. Okay. But then we'll write a formula in terms of y because y will become y by 2. Okay. Same formula I've written, but then this instead of 2y I'm putting y. So y will become y by 2. Okay. Same formula it is expressing in terms of cos y. Now cos y value we have cos y is minus 3 by 5, which is 2 cos square y by 2 minus 1. Okay. So take this minus 1 on the left hand side, which will be plus 1. Okay. So plus 1 is equal to plus 1 and plus 1 minus 3 by 5 plus 1 minus 3 by 5. Okay, just a second. So 1 minus 3 by 5 is equal to 2 cos square y by 2. I'll show you the previous slide. See, I've taken this minus 1 over here. Okay. So this will be 5 minus 3, which is 2 by 5. 2 cos square y by 2. 2 is getting cancelled. So cos square y by 2 is equal to 1 by 5. So cos y by 2 is equal to square root of 1 by 5. Okay. So I think that is the answer. Cos y by 2 is equal to root of 1 by 5. Okay, but then I think we should take a negative value over here because it's the third quadrant and cos value is negative over here. Fine. Okay, so let us go to question number 14. Let's take question number 14. Derive formula for the following in terms of 2 theta and then in terms of theta. Now see, sine 2 theta is equal to 2 sine theta cos theta. Okay, therefore they are asking sine 4 theta. What is sine 4 theta? Sine 4 theta is equal to 2 sine 2 theta cos 2 theta, right? They are asking cos sine 4 theta in terms of 2 theta. That we have done. Now, same way, sine 4 theta has to be expressed in terms of theta, right? So, what we are going to do is here and here, I'm going to use half angle. So, 2 sine theta cos theta, and you can write 2 cos square theta minus 1. Okay, so this will be 4 sine theta cos theta into 2 cos square theta minus 1, right? So, sine 4 theta is expressed in both the ways. Sine 4 theta is equal to 2 sine theta by 2 cos theta by 2. Okay. And sine 4 theta can also be written as 4 sine theta cos theta 2 cos square theta minus 1. So 4 theta in terms of 2 theta, 4 theta in terms of theta. Theta throughout on the right hand side. Okay. Next thing is cos 4 theta. Okay. Just a second. Cos 4 theta is equal to, okay, first I'll write down the formula for 2 theta for your reference. We have learned that way. Cos square theta minus sin square theta. Okay, this is the basic formula. Now cos 4 theta will be cos square 2 theta minus sin square 2 theta. So we have expressed this in terms of 4 theta in terms of 2 theta. Okay. Now they're asking to express the same thing in terms of theta. So first I'm doing this. I'll take the squares outside. Now put the formula. What is cos 2 theta? You have 4 formula. You can put any one, but then avoid the tan formula. So I'm just writing here 2 1 minus 2 sin square theta, or 2 cos square theta minus 1. One and the same thing, guys. Okay. Minus 2 sin theta cos theta, the whole square. First bracket a minus b the whole square. 4 cos raised to 4 theta plus 1 minus 4 cos square theta minus 4 sin square theta cos square theta. Okay. Now the sin square theta, I'll just write it as 1 minus cos square theta. So 4 cos raised to 4 theta minus this entire thing. Put 1 minus cos square theta over here into cos square theta. Okay. Now what you do is you simplify this, multiply cos square, multiply minus 4 cos square within the bracket. Initial terms will remain the same. So this will be, see, I'll show you once again. I'll multiply this minus 4 cos square theta within the round bracket. So 4 cos square theta cos raised to 4 theta plus 1 minus 4 cos square theta. Okay, these are the initial terms. This I have written first. These 3 terms I have written first. Minus 4 cos square theta into 1 is minus 4 cos square theta. Plus, why plus? Because the minus and minus will be plus. Minus is plus. 4 cos raised to 4 theta. Therefore, cos 4 theta can also be written as 4 cos raised to 4 plus 4 cos raised to 4 is 8 cos raised to 4 minus 8 cos square theta plus 1. Okay, this minus 4 will also sum. So we are writing cos 4 theta in terms of theta now. Okay, and at the same time, we had written it in terms of 2 theta as well. Now tan 4 theta is sin 2 theta upon cos 2 theta. All those values we have. Sin 4 theta upon cos 4 theta. So what is sin 4 theta? We had calculated it earlier, sin 4 theta. Okay. And then what about cos 4 theta? See, sin 4 theta, I'll show you. This is sin 4 theta upon cos 4 theta. Cos 4 theta is over here. So you can divide this two. And then you have to express this in terms of 2 theta also. In terms of theta also. So instead of dividing these two values, in the next step, you divide this value with this value. With this value, okay? To get the value of tan 4 theta. Okay. Otherwise, we can use one more way. Okay. Tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. This is the basic formula, but then we require tan 4 theta. 2 tan 2 theta, 1 minus tan square 2 theta. Okay. This is 4 theta in terms of 2 theta. Now, same you simplify over here. Replace the value of tan 2 theta. What is tan 2 theta? 2 tan theta upon 1 minus tan square theta divided by this entire box bracket 1 minus tan 2 theta value 2 tan theta upon 1 minus tan square theta the whole square. You have to simplify this so that tan 4 theta will be expressed in terms of tan theta. Okay. Let us go to question number 15. Question number 15. So, question number 15, sine alpha is equal to 3 by 5. So, sine 3 alpha, they are speaking about sine 3 alpha. So, that is 3 sine alpha minus 4 sine cube alpha. So, you can put the values of sine alpha over here. Sine alpha is given. Fine. Okay. So, this is how you calculate sine 3 alpha using triple angle formula. Now, cos 3 alpha, 4 cos cube alpha minus 3 cos alpha, 4 into cos cube minus 3 into this. Okay. And we have this value. Oh, we don't have this value, sorry. So from sine alpha, we can calculate cos alpha using triangle method. Okay, so this is 3, this is 5. So this will be 4 by Pythagoras theorem. So this will be 4 by 5. Okay. Right? So guys, one more thing we need to take care of over here in question number 15 is, see, I'll tell you one thing. First of all, the formulas are very clear written in front of you. You have to use triple angle formula, but then there will be two solutions. I'll tell you why. Okay. So from here, get the value of cos alpha, and that you can put in this bracket and this bracket. So sine alpha is 3 by 5. Sine is positive. Sine is positive in first and second quadrant. So the answer will be in first and third quadrant, first and second quadrant. Okay. This is sine A. Sine alpha. Okay. Now by triangle method, this is alpha. This is 3. This is 5. This will be 4 by Pythagoras theorem. Okay, this will be 4 by Pythagoras theorem. So cos alpha will be 4 by 5. Okay, but then you have to take both first and fourth quadrant. So it will be one's positive and one's negative. Okay, so in solution number 1, you'll have only quadrant number 1, where sine alpha is equal to 3 by 5, cos alpha is equal to 4 by 5. Now this values you can put it in this formula, sine alpha and cos alpha, sine 3 alpha and cos 3 alpha, and tan 3 alpha is sine 3 alpha upon cos 3 alpha. Okay, and in case 2, okay, that is quadrant number 2, sine alpha is positive, but then cos alpha is negative. Okay, now put these two values, okay, in this formula, sine 3 alpha and cos 3 alpha. So make a separate solution for both the cases. And tan 3 alpha is sine 3 alpha upon cos 3 alpha. Okay, that was question number 15. Let us go to question number 16. Okay, 2 cos theta is equal to x plus 1 upon x, and we need to prove something. We need to prove 2 cos 3 theta is equal to x cube plus 1 upon x cube. Now see, there is x cube plus 1 upon x cube over here. So somehow we need to get those cubes, and we'll get those cubes only by cubing both the sides. So I'm cubing both the sides. Okay, I'm cubing both the sides. Fine. So 8 cos cube theta is equal to a cube plus a plus b the whole cube. So a cube plus 3a square b plus 3ab square plus b cube. So x 1 upon x 1 upon x, and this is 1 upon x. So 8 cos cube theta equal to x cube plus 3 x square into 1 upon x. So this x and this x will get cancelled. So we are left with x over here. 3 into x plus 3 into, now this calculation, x into 1 upon x square. So this and this is gone. So this is 1 upon x plus 1 upon x cube. Okay, this is 1 upon x cube. Okay, right? So now see, we have simplified till here, and we got our x cube plus 1 upon x cube. Okay, somehow we got that. Okay, now let's park this over here. So we'll just park this over here. As I said, we'll keep it as it is. Okay, now we'll go back to the proof that is required. They are requiring 2 cos 3 theta. Now first of all, cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Multiply 2 on both the sides. Why to multiply 2 on both the sides? Because we require 2 cos 3 theta on the left hand side. Just check the problem. So multiply with 2 on both the sides. Okay. 3 into 2. Okay, and this will be 4 into 2. Right? Now this is what is required. Now we have the value of 8 cos cube theta. So this 4 into 2 will be 8 cos cube theta. We have this value. And this 3 cos theta, sorry, 2 cos theta value also we have. So I'll write this 2 into cos theta. I'll not multiply 3 into 2 and make it 6. Now 8 cos cube theta, we have this value, x cube plus 3x plus 3 upon x plus 1 upon x cube minus 3 into 2 cos theta. 2 cos theta value we have, x plus 1 upon x. So we are going to open this bracket. So x cube plus 3x plus 3 upon x plus 1 upon x cube minus 3x minus 3 upon x. I have multiplied that round bracket over there. Okay, with 3. Fine. So 3x is gone, 3 by x is gone. So this is x cube plus 1 upon x cube. So this is equal to the RHS. Right? So that was the end of question number 16. Let us go to question number 8 right now. Okay. Using half angle, find the exact value of sine 15. They are asking you the value of sine 15. Now sine 15, if we divide 15 by 2, the answer is 7.5. 7.5 is not a standard angle. So we don't have to divide 15 by 2. But then if we multiply 15 by 2, it is 30. Right? So from 30, we have to come back to 15 for sine. So how it is done? Let's see. Sine 2a is equal to 2 sine a cos a. So sine 30 is equal to 2 sine 15 into cos 15. So I guess we have this value sine 30 and this value we know, but then we don't have this sine 15 value and cos 15 value. So this formula won't work over here. Okay, let's think of a better option over here. We have to go to the cos formula. Okay, now see, cos 2a is equal to cos square a minus sine square a. So cos 30 is equal to cos square 15 minus sine square 15. We have the value of cos 30. This is required, but we don't have the value of cos 15. Okay, let's check some other formula over here. We can write cos 2a as 1 minus 2 sine square a. Okay, so cos 30 is equal to 1 minus 2 sine square 15. Now see, we have only one unknown over here, that is sine 15. So this formula is quite applicable in our context. Okay, fine. So cos 30 is root 3 by 2, 1 minus 2 sine square 15. So 2 sine square 15, 1 minus root 3 by 2, 2 minus root 3 by 2. Okay, so 2 sine square 15 is 2 minus root 3 by 2. So sine square 15 is 2 minus root 3 by 4. Cross multiply 2 on the other side. Which 2? This 2. This 2 multiply over here. 2 minus root 3 by 4. So sine 15 will be square root of 2 minus root 3 by 4. Okay. Take the entire root. So this will be 2 minus root 3 upon 2. Because 15 degrees in first quadrant, so the entire value will be positive. Okay. That is the final answer. Now second sub question is sine 292.5. Okay. Now, if we divide this by 2, we'll still get a decimal value. If we multiply this by 2, 292.5. If we multiply this, we'll get, let us check, 292.5 into 2, that is 585. So from 585, we need to get over here. Okay, now again, see, I'll go directly to the formula. Cos 2x is equal to 1 minus 2 sine square x. Okay, so cos 585 will be 1 minus 2 sine square. The half of 585 is 292.5. Okay, now this value you can calculate using the divide by 90 method. Cos 585, so 585 divided with 90, 9 6 are 54, so this is 45. Okay, so this is cos 6 into 90 plus 45, 6 pi by 2 plus 45. Where is 6 pi by 2? 6 pi by 2, 0 1 2 3 4 5 6. 6 pi by 2 is over here. Plus is in the anti-clockwise direction. In this quadrant, your cos is negative. And x-axis, 6 pi by 2 is on the x-axis. Cos remains cos. So this is minus 1 by root 2. So we got this value. This is minus 1 by root 2. Okay. 1 minus 2 sine square, 292.5. Now you can rearrange the terms. 2 sine square 292.5 is equal to 1 plus root 2. 1 plus 1 by root 2. Root 2 plus 1 upon root 2. Cross multiply these two down over there. So sine square 292.5 root 2 plus 1 upon 2 root 2. So sine 292.5. Okay, the entire root 2 plus 1 upon 2 root 2. Okay, but then as we checked, we need to check 292.5. So 292.5 is the third quadrant, and in this particular quadrant, in this particular quadrant, 292.5, third quadrant, the sign is negative. So we put a negative sign over here. Fine. Now, one or two problems are still remaining from this particular exercise, which you need to prepare for your exam. That will be covered up in the next session. Yeah, thank you.